All right. Good afternoon, everyone. Welcome to our latest seminar for the U.S. Society for Ecological Economics. My name's John Palomoney. I'm the president of the society, and this is a continuation of our series on putting ecology back into ecological economics. Last week, if you were able to join us, you saw a seminar on coral reefs, the science component. And this week we have an excellent seminar on the economic aspect of coral reefs. Today's speaker will be Kirsten Oleson, Associate Professor of Ecological Economics at the University of Hawaii, Manoa, correct? Did I pronounce that
No.
okay-ish?
Yeah, University of Hawaii at Manoa. But yes.
I struggle with English. So her,
Well, that's Hawaiian, so that's Olelo.
Her fields of interest are in ecosystem services, decision science, and environmental valuation. And we're extremely grateful and honored to have her speak today. And with that, I will turn it over to you. Thank you so much.
Yeah, mahalo, John. Thank you so much for the invitation today. Yes, it's fun to see friendly faces. And I just want to say at any point, if anybody wants to unmic and ask a question, please let's make this more of a talk story session. Because there's a lot that we could talk about and integrating it with the amazing talk that I got to watch after the fact by Sam last week. Maybe there's connections that you see and would like to talk about, and I'm more than happy to do that. This is, I'm going to give a talk about this ongoing project to do ecosystem accounting of the coral reefs of Hawaii. So it involves a little bit of science, a little bit of economics. And so let me just proceed if I can get the slides to move forward. Hold on one sec. Never as easy. Oh, there we go. Before I go any further, I have to acknowledge the funding that has come to my research group from the Pew Charitable Trust, from the Department of Agriculture, Hatch and McIntyre Stennis programs, the Pacific Islands Climate Adaptation Science Center, NOAA, and Sea Grant. And in that, I would like to acknowledge our colleagues at NOAA in particular, as yesterday was a really hard day for all of them. I want to give a call out to all the federal workers and everything they do and acknowledge the trauma that is being put on them these days. And that hand was my son and I painted it for our local protests. So, oh, there. This is my team. None of this would be possible without the input of these amazing academics. So the work I'm going to be talking about, Ella is an economics PhD student who worked on the fisheries valuation with me. Louis Chua is a PhD student in my lab who worked on the geospatial processing of ecological data. Almarie Sarah is my data manager. Oh my gosh, what would we do without her? Carlo Fezzi was a visiting economist from University of Trento, working on the recreation model, which was then picked up by Ashley McKenzie. She was a postdoc, now assistant professor in our department, and a visiting scholar, Anders Dugstad from Norway, came. And all of this work has been advised by colleagues from various state, federal, and academic agencies. So just an enormous call out to all of these collaborators. Okay, so I hope all of us after last week appreciate coral reefs for their incredible ecology. They're also really important, especially to places like Hawaii and the Pacific Islands, because they underpin our economy and our resilience. The various Pacific islands depend on coral reefs for tourism. So on the left there is the iconic Waikiki beach on my island, on the island of Oahu. They underpin cultural practices like this hukilau in the middle of a traditional fishing. And they feed a lot of people. And of course, we wouldn't be able to surf. A lot of our surf breaks are driven by coral reefs. And this is actually a really large economy as well as wellness practice. Um, okay, so the idea here is that we account for all sorts of things in our statistics, nationally and at the state level. But we do a really poor job of understanding the contribution of ecosystems to human well-being and to our economy. So there is a framework. I don't know if all of you are familiar with it, so forgive me if I am telling you things you already know, but the system of environmental economic accounting, this is a statistical standard kind of negotiated and developed by statistical agencies around the world with a secretariat housed at the United Nations. But just to be clear, this is, it's not a UN imposed statistical standard. It's something that all countries have collaborated on to create. So, everybody is familiar with headlines that say, oh, GDP growth and, the reporting on GDP as if it's a meaningful indicator. It does one thing relatively well. It tells us the production of the economy, the output of the economy, of marketed goods and services. But it tells us nothing about the underpinning social and environmental basis of our well-being. So the idea here is this accounting framework was developed to start to track how the economy is connected to the environment. So the first iteration of this is the central framework, which looked at some of the aspects of the environment that were more easily accounted for, so like fisheries and timber. And then in 2021, what was experimental ecosystem accounts were codified, which gave us methods to account for ecosystem extent, condition, and services. Now, to be clear, this is one methodology in many, many methodologies for natural capital accounting. So there's often conflation of terms. I think we still, as a community, need to map out what we mean with the different terms. This framework that we're applying is specifically meant to harmonize with the system of national accounts. So because of that, and I'll get into this, we have to make some, pretty odd choices that as environmental economists who are used to doing cost-benefit analysis based on kind of welfare impact, it might be like your fingernails on a chalkboard, what I'm going to tell you we have to do. Right. So we embarked on this effort to do accounting as at a state level, a pilot level, to inform state decision making. And to give a little bit of a background on this complicated diagram, so on the left-hand side, we have the environment. And the idea is that we collect data on ecosystem extent and the ecosystem condition. And that then translates through ecosystem services to society. So we have production and consumption activity that is embedded in the economy, but we also have benefits that flow both from production and consumption activity, but some that are external to the economy. So examples might be recreation, right? There is of course a recreational sector. Some of that may be in people's income, et cetera, and that's captured in GDP. But the people who just, I walk down to the beach and not to rub it in, but I walk down to the beach and I go hang out, right? And that's not captured. So what we're trying to do is really quantify and value those benefits so that we understand when we're making decisions about development or other choices in public policy, what the trade-offs are. Okay, so A little bit more information here. We have like the ecosystem extent accounts. So this is an organization of existing data on ecosystem types within a spatial area. And then that's linked to the conditions of those ecosystems. And specifically, you want to choose conditions that are indicative of the ecosystem's ability to function to deliver ecosystem services, right? So there are a lot of things that we could use to describe ecosystem condition, but you have to have enough of an ecological understanding of how that's important for delivery of ecosystem services to society. And then we use those services. We eat the food, we surf on our waves, and we get benefits from that. Okay. So this is from a really cool recent report by Rivaldo et al. That does a great job in kind of layman's terms of laying out what is natural capital accounting. It's a gray literature report from NYU Law School. And what we see here on the left is the forms of capital, right? Classic kind of economics. We've got human capital, manufactured capital, and natural capital. And what we see is that like the red arrows and the red boxes are what's included in national accounts and GDP. But we know the flows from these capital assets are larger than that. And the intent of the ecosystem accounting is to expand the arrows that we're accounting for so that we really understand those dimensions of the economy. Okay, so this is my project. We're applying natural capital accounting to Hawaii. This specific project has 4 objectives to build coastal ecosystem accounts. And I'm going to report mainly today on objective 1 because it's an ongoing project, but the next objectives are to evaluate the contribution of coastal ecosystems to the economy, support use of the accounts in planning, policy analysis, and macroeconomic reporting, and to fortify the capacity to operationalize these accounts within the statistical agency of the state, as well as any other users for spatial planning, et cetera. All right, I'm going to bring you to Hawaii. So on the left-hand side is a kind of a depiction of Hawaiian islands. They're high islands, high volcanic islands, steep slopes. And so the islands are largely divided into very distinct watersheds. And the reason this is important is because in accounting, you have to define an accounting unit. So what geographic area are you going to report your data, right? And so what we did was we chose to do it based on this Hawaiian concept of moku. So on the right-hand side, these are all of the different watersheds on Maui. So these are kind of hydrogeographic units, the equivalent of that. Interestingly, the traditional Hawaiian management institutions largely followed these watershed lines. And they're called ahupua'a. That's the Olelo word for the management units. But for coastal accounting, we chose a slightly larger unit, which is called a moku. And so the Hawaiian management institutions traditionally had, this watershed scale. They had like 3 dimensions, even smaller than the watershed scale, where resource use was governed. And then the moku scale was kind of a collaborative scale of governance, which made more sense for coastal environments that really interact. The fisheries, for instance, exist more at this scale than the watershed scale. But like water and food, et cetera, was all at the smaller scale. So we chose moku as our ecosystem accounting unit. So you're going to see these divisions throughout the presentation. Okay, so to build the extent accounts, Louis collected data from all over. interestingly, we had uh, a number of different sources of benthic data. So what Sam was talking about yesterday, I was like, oh my God, I wish we had that for Hawaii, right? But they're concentrated on all these spectacular areas, arguably less useful than for places where people are. Um, but we chose a relatively simple benthic categorization for the nearshore environment. Um, this was a whole choice that I won't get into, but when building these accounts, as we learn, trying to figure out what the best data sources are, sometimes the most precise are not the best because they're a one-off endeavor. So we worked with the state to decide on what would be most useful for the Division of Aquatic Resources. And then similarly, we compiled a whole lot of information from different agencies to map the habitats or the ecosystem types on land. We're really focused in the work in Hawaii on integrating land and sea because they're integrally connected. What happens on land nearly instantaneously shows up in the nearshore environment. So just to be really boring and true to my economic roots, I'm going to show you a table, but only to demonstrate that this is the type of product that the ecosystem accounts produce. So you get, across the top, we've got the different types of ecosystems, at least terrestrially. And then, year by year, opening stock, additions to stock, reductions in stock, closing stock, right? So it's just a summary of that spatial data. And we can report that. Oh, go ahead.
Is this firsthand data?
Is this our data? Yeah, this is one of our early data. Yeah.
So did you send people out in the field, or did you use aerial photography, satellite imaging?
Yeah, going back here. So we used data from USGS. So we pulled in data from the land use mapping. We used data from Fish and Wildlife Service on wetlands, from NOAA CCAP program, coastal mapping program. So and the state of data. So we had for instance, agricultural data from the state that was much more precise than what was showing up on the land mapping, et cetera. So there's a lot of corrections that we did where we pulled different data sources together.
But you didn't generate any data from your
No,
tool.
we didn't. No. I mean, the intent of the, what we're trying to do is use existing repeated data sources and show how bringing them all together provides important information about status and trends.
Okay, good.
Yeah. There will probably, I know for sure, like one of the key lessons of doing this is the number of data gaps. But that's kind of part of the adventure of trying to compile these. Okay. And then so you pull this information together. What is it good for? So you can create some analyses like this, where you can look by moku at the change in cropland over different periods of time. You can map, how did one type of land get converted into another type of land? Like, what are the trends there? So, I mean, arguably this information in and of itself, this ecological data can be really useful for various purposes, not even getting into the economics of it. So we are building a user interface. This QR code is a very, very early version of it. My data manager is building a really cool tool that managers can use to examine the extent and the condition data, but it gives you an idea. You can choose your island, you can choose your moku, you can choose your habitat, and a bunch of different analytical questions. So we're in the process of developing the tool. Okay, and so that moves us on to the conditions of these ecosystems. So I mentioned that it's kind of a combination of extent and condition necessary to have to produce the potential of ecosystem services. And so another endeavor that Louis Chua undertook was trying to compile important conditions that span physical, chemical, compositional, structural, functional, and landscape. And again, Sam blew my mind on some of these data that he has for these amazing sites that he works in. And just like thinking about the integration of what we're trying to do with the upcoming technological tools. Like so much of this, I feel like is going to be possible in the near future without, the hard efforts of poor Louis trying to find these data elsewhere. So so we collected data from, again, many sources to try to find information on various conditions of the coral reef ecosystems and upstream areas. That our expert panel helped us vet to make the case, the logical chain between the ecosystem type, ecosystem condition, and delivery of services. And again, like some really just kind of initial graphs to look at kinds of analyses that we are going to put into our tool. You can look at condition trends across years by moku. This is coral cover. And we see like this anomaly in Halava, which doing this helps us go back and talk with experts who are from these places and kind of validate the information that we have in our data sets. Okay, so that brings me to the modeling and valuing of ecosystem services, which is was the whole point of kind of my project, but we had to do all that ecological work first. And we focus on 4 really important services here in Hawaii and across the Pacific. Fisheries. So we have both shore and boat-based fisheries, both commercial and non-commercial, and subsistence. And then what we did was I'll get into it, but we pulled together fisheries data, a lot of which it's a data poor sector. Then recreation, I'll also talk a bit about this, trying to understand the recreational value of our nearshore area. Tourism, which is more the visitors, not the residents, and shoreline protection. One note here, and this is your fingernails on chalkboard for a lot of valuation people, is that because we're using the SEEA, and we really want to make the connection to the system of state accounts or system of national accounts, we are not valuing these services at their welfare value, right? We have to exclude consumer surplus for those of you who do this work. It only includes producer surplus. So we value these at exchange value. So this is the values at which goods, services, labor, or assets are in fact exchanged in the market or could be exchanged for cash. They do allow for, if a market existed, that's the exchange value. And this is really important and a kind of a topic of active discussion in the accounting community. But it's distinct in the SEEA from kind of broader natural capital accounting that's used for policy analysis or cost benefit analysis, et cetera. So just putting a pin in that. So fisheries, yeah, as I mentioned, we've got kind of really small scale fisheries. Uncle goes down, throws a net, comes home with dinner. All the way, up through the small boat fishery. And then with pelagic, we have the massive tuna fisheries, but we exclude those from our analysis. But we do try to include this, the really small scale and the small boat commercial fisheries that fish, within 12 nautical miles. So what we did, and it's a shame I couldn't get the GIF to work. I'm technologically challenged, but we pulled together both commercial and non-commercial data and assigned these data to moku of where the fish were caught. And then we developed a methodology, because in the accounting, the fisheries have to be assigned to an ecosystem type, right? Okay, so, our data say, the boats were here, they caught fish, they caught so many fish, these species. But how do you then say, was this a coral reef? Was this over soft bottom? Was this pavement? And so this took a lot of discussion with fisheries ecologists to kind of decide on how to do the assignment to an ecosystem type. Various people have looked at different ways to do this. Some have gone as scientific as isotope analysis, right? But that's just not practicable for us. So others have done life history. So how long the species have spent in a certain habitat and assigned it that way. Yet others have assigned energy, right? How much energy comes from each habitat. Anyway, there are so many ways to do that. And this is a ripe area for research of how we might standardize the assignment of the ecosystem service to an ecosystem type. But we developed ours where we just made a probability of based on life history of these different species, and we assigned them across the ecosystem types. So that's still really a prototype of how we're doing it. Okay, and then we valued both commercial and non-commercial fishery through Ella did this, a very grueling process of trying to determine resource rents for all the species. And for commercial fisheries, we've got pretty good data from NOAA because we have catch earning reports. For small boat, we've got the NOAA's small boat information, but that's incomplete. In order to figure out the cost and the price of some of the fish was a lot of sleuthing because these are really, really multi-trophic fisheries. And then, of course, how do you assign costs to, the guys who walk out onto the reef or are doing scuba spearfishing, et cetera. So this was some work that we're going to be publishing soon, and I've presented in a number of conferences to try to kind of codify those methodologies. But interestingly, just looking at some of the trends, we see commercial fishing exchange value dropping over 1997 to 2001. That's the top graph in almost all islands. The non-commercial exchange value fluctuates a lot more. So yeah, we're looking at these trends and trying to understand what's driving them. But this is a really important food source for local people. So that this, important information to get out there. The bottom line is, though, that when you try to try to use methods for valuing fisheries that kind of are standard, price minus cost, most of these small scale fisheries are negative. They don't make up the labor and input costs with the market prices, which is interesting in terms of cultural services. Okay, moving on briefly to recreation. Again, our iconic beach. arguably this picture is more tourism because locals avoid Waikiki, except for the surf. We don't go to the beach there very often. But the beaches are incredibly important. The shoreline is really important for residents' well-being. Most of us live here because of the access to the coasts. So a few years ago, working with Carlo Fezzi, we built a travel cost model to estimate the recreational demand for recreational sites on Maui, and then isolated the value of the coastal sites. And so this gives us a random utility model where we got the preferences of close to 400 Maui residents, and we tied those to the ecological conditions and site characteristics of the various recreational sites to get their demand function. So what we decided to do was to extend that model to other islands. So we did a benefit function transfer, and we collected all the same ecological condition and site characteristic data for 700 sites around the main Hawaiian Islands. And Ashley Lowe McKenzie is producing a paper. Oh, sorry, I forgot to click forward. These are some of the various beach sites, only the key top ones across the islands. We did the benefit function transfer and calculated the annual value of these sites for resident recreation. And this is a result of in the nearshore environment. It shows our modeled coral reef loss. So this is a whole model that I could have talked about, but this whole presentation would have been 3 hours and something. But we built an ecological model that is capable of projecting what the reef will look like under different scenarios of climate change and land-based pollution. So this is an output of that model and part of Ashley's paper, where we projected this reef loss under SSP1 at 2100. And then on land, you see the colors. The warmer colors are the larger welfare losses from the loss of those reefs. And what's really interesting from applying this spatially explicit recreational model is that you can map where the welfare losses occur from the coastal decline. You don't have to assign it. Like a lot of times you'll see it just assigned to that area where the coral reef decline is. But because people travel across the island to go visit sites, this helps us distribute that welfare loss. And then what we did was we downloaded the data before it disappeared, the environmental justice layers, the EJ40. So we could look at, are those welfare losses how are they affecting disadvantaged communities who are mainly Native Hawaiian in Hawaii? Okay. So kind of next up in our research endeavor, recreation goes hand in hand with tourism. Tourism is an incredibly important economic sector for us. As we learned in COVID, it has both benefits, and when nobody was here, it was really nice. We love you all, but so this is just from a couple of airlines, like how many people are connected to Hawaii and where they come from. So we're developing a tourism estimate of the welfare losses and the losses from tourism and the value of the ecosystem services contributing to tourists, because tourists come here for a lot of different reasons. They come from a lot of different places. So teasing out the ecosystem service value to the tourism exchange value right? They spend a lot of money here, but how much of that is due to the environmental attributes of Hawaii? So this is a non-trivial question that we're grappling with, trying to build similar models to how we did it with the residents, but from information. We've bought mobility data. So we are able to track where people come from, where they stay, and where they go while on vacation. So this is a big data project that Ashley and I and a number of collaborators in the econ and the tourism industry management school are working on together now. Kind of scary. I didn't realize like how much information you can just buy from the cell phone that you carry in your pocket. Okay, the other thing we're doing is working with partners at UC Santa Cruz and USGS, who have a large effort to value the impact of coral reefs on for coastal protection. I don't know if you probably don't get any news from Hawaii where you are, but houses are falling into the ocean. Across the US affiliated Pacific and other Pacific islands, people are being forced from their homes. There are cultural sites destroyed. And so one of the efforts is to understand the role of natural habitats in coastal protection. Reefs in particular are important because they are really complex structurally. And as waves start to come into the nearshore environment, they're very, very good at dissipating wave energy. Yeah, so this is some ongoing work. If funding gets released, that will continue. Okay, before I close, I just wanted to bring into this space my former PhD student, Alohi Nakachi's work. I want to acknowledge how our methods and economic valuation are really rooted in one way of seeing the world, and that this is quite in opposition to an indigenous worldview. First, as a settler brought up in the dominant world paradigm, nature is a thing to be used. So, ecosystem services flow from nature to benefit people. But for indigenous people, nature is kin. There is a reciprocal relationship between people and nature. And so this idea, the whole model that I just spent 30 minutes talking about, is really in contradiction to the place where I'm living and the resources that are here and how Native Hawaiian people view them. And University of Hawaii is a Native Hawaiian place of learning, and so my intent is to engage with that responsibility by supporting efforts of Native Hawaiian scholars to apply their knowledge and worldview, and try to figure out how we can use some of that insight in our kind of standard neoclassical, if somewhat radical neoclassical research. So in parallel to the accounting work, I was working with Alohi and a collaborator, Kirsten Leong at NOAA Pacific Islands Fisheries Science Center. And Alohi is Kanaka Maoli, and Kirsten is also tied to this place, grew up here. Alohi's from West Hawai'i Islands, and her genealogy is tied to that place. So her first chapter focused on how to elicit different types of values that people hold for their relationships with the environment. And she uses what's called a two-eyed seeing approach. I'm not sure if you are all familiar with this, but it's a very foundational to some of these indigenous scholars who are trying to straddle Western and indigenous sciences. So it draws, she sought to really draw on the strengths of both indigenous science and the dominant science in used in marine management. Okay, so just really briefly, I want to throw this out there because I hope this community can help me figure out how these two kind of research things start to mesh, right? Because we're really just starting this, right? So to give you an idea, this is one of her products. So as I said, like assigning a dollar value, an exchange value, or even a welfare value to the environment is like, what? Why would you do that? You can't do that. It's totally off limits to do that. So she developed this level of intensity framework for talking about the value of the environment. So when people she would ask people how do you value the environment, and they talked about like, do you feel the connection of the environment kind of up here, visible headspace, right? Is this it's just kind of like, it's very a little bit superficial, intellectual, right? Or do you feel it kind of in your heart, and does it touch on your feelings and senses, the smell, etc.? Deeper, at your belly button, this is a really important uh, kind of point in your body and in your soul, that you have connection to it. You feel it in your gut, right? Or do you feel it in your current life and inner circle, or your future? And then, or are you like grounded? Is this your grounding? Does this connection you have to the environment come from your ancestry and genealogy? And initially I was kind of like, okay, Alohi, so is this like, okay, if these aspects, these services you're getting from the environment, or using our language, if they're up in visible headspace, does that mean you can trade them off, but you can't trade off like visible headspace connection and value with ancestry genealogy? And she's like, yeah, maybe, but no. And so, but we were trying to develop this method that's akin to valuation, in the sense that valuation helps us understand trade-offs in decisions. But we didn't get all the way there with this. Then she did deliberative workshops with groups of and individuals to understand, when she would mention, she mapped each one of these cultural services in the rainbow circles onto this values of intensity, to understand like, maybe like a deeper value could be equated to larger dollar amount. She would kill me if hearing me say that, but the essence is kind of there. And these were the words that people came up with when she had them talk about what these ecosystem services in around the circle meant to them. As well, she was like, what does inspiration mean to you? What does recreation mean to you? What are words you use to describe these services? And came up with word maps. And one thing that came up again and again was responsibility to the environment. Kuleana is a concept of reciprocity, obligation, care, and connection, right? So this idea of kuleana came up again and again. So she chose that as one of the ecosystem services, because it's important to note that like these words that we use in cultural ecosystem services do not resonate here, right? So what she tried to do is be like, okay, what are your words for the services the environment provides? And this was the word cloud that she got from her interviews. Then she drilled in on kuleana and responsibility, and she had people map those, like where do you feel a connection, a responsibility to place. And again, she focused on her home of the western shore of Hawai'i Island. And she then like asked them to drill down and be like, okay, well, what underpins that kuleana, that feeling of obligation, responsibility, connection, kinship, and tried to, you know, put more granularity into those concepts. Are they storied places? Is it a connection to your family and genealogy, skills and calling? And you get a map, which, while not a valuation map, nonetheless contains incredibly rich information about the cultural services that these areas are providing to people from that space, and arguably can be much more informative than the or complementary to the work we're doing in ecosystem accounting. And just to explain the graphic on the left, so this was trying to crosswalk the two efforts of defining what cultural services were to people and having where they fall on the levels of intensity framework. So that's what I have for you today. I'd be happy to chat about anything and everything. But mahalo nui loa. Thanks for being here.
Thank you very much. That was very interesting and tied in very well with last week. So thank you very much. Awesome. Are there any questions or comments from anyone?
I have a question.
Good afternoon. I have a question.
Oh,
people had their hands up.
Yeah, no, there was no one with hands up, John. So I couldn't. It was two at once. So let's go with Roberto first, and then we'll go with Corinne.
Okay, thank you. Good afternoon, everyone. Congratulations, Kirsten. Is a good researcher. For me, the service, especially the ecosystem service, is very important because the interview in the economy and the environment. But my question is at the carbon sequestration. You have information, in special the markups of the carbon sequestration in this moment, because it's very important incorporate of the ecosystem accounts, but the middle of the mangroves of the important in the environment. Do you understand me? Excuse me,
yes. No, I understand you. So I have a shocking thing to tell you. Mangroves are invasive in Hawaii, and we remove them. When I moved here, I nearly fell off my chair learning that. So the carbon sequestering, its carbon sequestration in Hawaii is different, than elsewhere, or the ecosystems that sequester carbon. So we don't have mangroves. We have some seagrass, but nothing like, in Coral Triangle or elsewhere. Terrestrially, obviously, our soils, we have every soil type but one in the world here. And that's an active area of research of, carbon sequestration on land. Turning to coral reefs, carbon sequestration in coral reefs is a really curious process. They are obviously a store of carbon. They're calcium carbonate, right? But live coral, depending on conditions, are actually a net emitter of carbon. And so the ocean chemistry, kind of the biogeochemistry of coral reefs are hard, to say the least. We obviously, ocean acidification combined with temperature increase causes the coral to bleach. and causes them not to accrete like more carbon, but that accretion could actually be a source of carbon emissions, bizarrely. So we don't touch on carbon right now. The science is still kind of out on the balance, and the NOAA scientists are deeply engaged in that question.
All right.
Thanks for the question. Karen, do you want to go?
Yeah, I thought I had unmuted myself, but I didn't. Thank you for an interesting talk. I attended an Ecological Society of America webinar yesterday about biodiversity credit markets, which turned out to be a little, well, I think they assumed a little too much for me, about how things work and stuff. But I think you put some more meat on the bones in terms of the specifics of how, the steps that you did. One of the things that then I wonder about, because we're sort of struggling with this at ESF, is how do you assign some kind of value to biodiversity? And what I heard from you, I think, is that you're doing it sort of by habitat type and multiplying by area or something like that. And I don't know if that's, I mean, you have some low diversity and you got some high diversity places. So that's one question I'd like you to consider. And then you've touched on bleaching, and I was wondering if you have developed sort of a bleaching cost function that results in, affecting the other things that you're focused on, the tourism and the fish and recreation, etc.
Yeah. Okay. So biodiversity. How I conceptualize biodiversity is that it's a risk mitigation element of the ecosystem, right? And so it is, in the classic Millennium Ecosystem Assessment, it's a supporting service. You call on it as when you lose a function, an important function in the ecosystem, right? It supports a function of an ecosystem that's important for the delivery of a service. So it's kind of way back in the chain, if you think of it that way. So, you have biodiversity, if you go back to the flow of ecosystem services, that, kind of bubble depends on the functioning of the ecosystem. And that functioning depends on having certain things in the ecosystem that enable that functioning. And if you lose one of them and you don't have anything to replace it, you lose the service, right? And biodiversity, this is how I conceptualize it. Biodiversity plugs in there and is like, okay, we support this. This is important for the functioning of the ecosystem. If we don't have it, we risk losing this function and this service, right? So you kind of have to almost create this probabilistic equation to figure out the importance of biodiversity for the service in question, right? It in and of itself, it's not something you can value, except, potentially people may get a warm, fuzzy feeling from knowing there's biodiversity out there, but then do they understand what that means and how it's measured? And right, that starts to get really nebulous.
That was what was interesting. This guy said that there are lots of investors willing to, pony up dollars, and they invest in it. A lot of pension funds, they said, invest in these markets.
Yeah, I guess. But what is it? Exactly. It's kind of like cryptocurrency. It's a social construct, right? There, even the ecologists are like, is it genetic biodiversity? Is it structural diversity? Is it?
Well, it's probably hierarchical.
Yeah. So that's yeah. I don't know a whole lot about the biodiversity market, quite honestly. But I mean, I know like with carbon market, something would seemingly be even more simple, right? You know what carbon is, you can measure it. It's also wickedly complex to put those markets together and to validate the additionality, right? And the what do they call it? The that they are actually getting a result from conditionality. Yeah. Okay. So and then your second question, was on the cost function. Not yet. For recreation, yes. Like, all of these valuations, and this is another tension with natural capital accounting versus a lot of the methodologies we have is that the non-market methodologies are good for marginal changes, right? But not for the total value, because that's kind of a nonsensical term. So for instance, we said in the Maui paper that Carlo Fezzi led, we said, okay, if we had a major bleaching event and lost a mortality event and lost the X% of reefs, and we distributed that in a meaningful way, and that cascaded through the fish, et cetera, what would the recreational loss be, right? So we do have, that's kind of what we're building, the functions, and then you can add up across the services that we're valuing.
Okay, thank you.
Beth, you had a question.
Thanks, John, and thanks, Kirsten. Thanks for this talk and just all the amazing work. I had two questions, which are maybe kind of wonky, just about the implications of what you're finding. So one is, are you or others looking at like what your estimates for the value of these types of natural capital are for existing estimates of like traditional capital services? Presumably, we are essentially overestimating the value of that conventional capital if some of the value really is flowing from our natural capital. So I'm wondering if you've looked into that. And then another type of implication I'm interested in is whether that negative resource rent you were finding necessarily implies a corresponding sort of offsetting cultural service that's just not being defined and measured.
Yeah, let me take the second question first. So yes, I mean, absolutely. And this is again, like in the accounting community, a lot of fishing is not just an activity for food, right? That's one of the fishermen said, no, it's to go out with my buddies and get away from the kids and wife, right? So how do you tease that apart, right? I think definitely indicating that, the price they're getting, whether they sell it out of the back of their truck, et cetera, but the ice and the gas, it's negative resource rent. And so I think that it's just the wrong methodology to apply to fisheries, and we have to figure out how better to do this. I work a lot in other Pacific islands, and giving fish to family members, having fish to bring to funerals or other life events, et cetera. I mean, it's a social obligation, right? And there's no price on that. Like, you're not buying and selling the fish, but and so there are a lot of cultural ties to fish in island communities. That the price minus cost it's one of those methods that makes a lot of sense in industrial fisheries that are run like a business, but it really does not make sense in assigning a value to the non-commercial and subsistence fishing.
John S., you had a question.
Oh wait, there was another question. Oh no, there was another question about the capital services. Yes and no. We haven't, we're so buried in the details right now of the ecology, getting the data together, et cetera. But I'm going to pin that, and I'm gonna talk with my team because obviously the intent is to bring it to that level, right? To the macroeconomic, to be like, okay, by undervaluing the contribution of the environment, like we're saying, like, that yeah, the traditional sectors, we want to be able to tease apart that arrow from natural capital into the production and showcase how important the environment is. And that's one of the things the accounts do. I didn't get into the supply and use tables that we're creating, but the idea is that these services, once we've valued them, get assigned to kind of industrial sectors that use them, right? So is it households? Like the recreational value flows to households, right? But the Coastal Protection Service, let's take that one as the example. Who's being protected, right? What industries are being protected? And so, their ability to produce that GDP output is largely thanks to the services of the environment.
Just a question from me. The impression I got from what you were doing is you're kind of hovering around the idea of ecological production functions, and to include your final thing about the social and esoteric and fundamental feeling kind of approach is it's almost like attribute theory. Like Kelvin Lancaster had this thing about that the outcomes are a vector of characteristics or a list of things that get consumed. And to me, it seems that you could almost map some of the conditions of these ecosystems, extent probably not so much, but conditions can imply certain types of ecosystem services, which give various things to the people. It's kind of a stretch. It's kind of a stretch, but you brought us there to that, to those.
Yeah, no, thank you for that. I did. I opened it up and asked for brainstorming. Yeah, I
do
think,
like it.
Yeah. Thank you for that, John.
Are there any additional questions? Okay, I don't see any. So I just want to remind everyone our next seminar is next week on March 7th at noon. And our speaker will be Sigrid Stago. She's an ecological economist as well. So we'll look forward to that. And with that, I want to thank you, Kirsten, again for a wonderful presentation. Very, very interesting, and it tied in extremely well with our talk last week. So thank you so much for sharing today. And thank you, everybody.
Good seeing you
Thanks
again.
for coming, everybody. Feel free to reach out.
Really enjoyed it.
Thanks, John.
Bye-bye.
Happy retirement semester. Bye.
Thank you.
Bye. Thank you.
Bye.